Perfect. So talking about examination mode, just remember that in order to input, first of all, you need to turn off your calculators. So in order to turn off, shift all clear, so it can turn off.
Mm-hmm.
And in order to put into examination mode, we need to press and hold cosine 7, and then press and hold, and then turn the calculator on with all clear.
Got it. And then we have yes or no, like enter examination mode for IB, yes or no.
Yes, that's the point. So F1 to confirm. There is a second message after this one. You need to press F2 in order to finally confirm into examination mode. And then everything that you have been put in the calculator, calculations, functions, data, is going to be hidden during the examination mode. And then once you take the calculator, you exit the calculator from examination mode, then you have everything back into your calculator.
Will it be able
Okay.
for us to go into examination mode right now, or is that okay?
If you want right now, it's okay because we're going to use only.
If you enter now, I think that if he enters now, then Giovanna, do you have your cable?
Yes.
Okay. And then we can just plug your calculator, and then we can see how to take it out.
Yeah. Anyhow, all the functions that we're going to use today, they are all able to be used with examination mode, so it's okay. So if you want to use it, it's just you won't be able to see some apps. For example, e-activity, you won't be able to program and some others. But
Okay.
for today, it's okay.
Did anybody want to see it on here? What it looked like?
Yeah, it's nice to check.
Once you turn it on, F1, there was another prompt, right?
Yeah, so it said
Yeah.
two to just continue, and then
Oh, so you can still say, no, whoa,
Yeah.
it was a mistake.
and then
Okay.
kinda-
Yes.
Okay, thank you.
There are two messages. One you need to confirm with F1 and the second with F2.
Because it's like calculator, computer. not
Yeah.
calculator.
Oh, but can't we do?
But that's the thing, right? We leave
Yeah, no, we can connect it to the computer too.
we leave the examination mode by connecting it to the computer and then moving any file into the calculator or out of the calculator.
Yes.
Okay. We don't have the cables. What?
So what's happening?
The cables. Let me.
So the cable is the mini USB that comes with the calculator. Just plug in the calculator into the computer, drag and drop anything, and then the calculator will exit examination mode. If you want to try right now, it would be nice. We have time. Okay. Believe Are you putting into examination mode just to be sure?
Some feedback. I don't know. It was weird.
It worked.
Yeah, it worked. We tried and it worked.
I just added.
Perfect. Perfect.
So you added a file
Yeah, I added DSL.
and then you disconnected from the computer.
I added, yeah, and then I deleted the file too.
Okay.
I don't know if it matters. I wonder if you can get a-
So just to make a a quick review about the functions. So here we had all the functions. Remember, just to let you know, um, normally I keep one empty list saved on my calculator. So here I have an empty list of functions in my Graph app. And remember, right here in Tools, we have Graph Memory. So it's nice to save a bunch of lists that you want to store in your calculator. And I always save the empty list into my list one, or one of the 20. So every time that I need to clear the list of the function that I have, I just go to recall and recall list one in my case. So it's very, very useful to have this empty list saved into your calculator. And what we did last time, we used to make some calculation with functions such as roots, minimum, maximum, and in order to check if you don't want to plot both functions, right here you can see that both functions will be plot in my calculator. I just go to the ones I don't want to and press F1 to unselect the function. So now I only Y1 will be plot. So once I do that, I can use shift in order to trace. So I go over the curve. Remember, I can input any number in order to calculate y. So for example, here I can input like -2, hit execute, and then I see the point, the coordinates -2 and 3. If I want to record this, like save this point, just press execute, and now the point will be cached into the graph.
Delman,
Yes.
um, where in the menu were you to go there?
So in order, I use, so let me exit and draw. So when I'm here, I have two ways of
But,
doing it.
but how do I go there? I'm really like, since I didn't have the calculator, I forgot how to, it was the
Okay.
graph, dynagraph.
So I draw I draw the function. Perfect. Let me just clear here. I'm going to make a review about this. So first of all, you have two options to go to trace. One, from here, you can go directly to F1.
Mhm.
So if I click F1 right now, this is trace. So I can move with right arrow to the right, left arrow to the left.
Okay.
In order to go to a specific point from the domain, just input the number. In that case, I use -2. So just go -2 and hit execute. So we have here enter X value. When I hit execute, shows me the point because both X and Y values are on my screen. And if you want to register the point, hit again, execute. You can see that the point turns bold. And now when you move over your graph, the point is there. Again, let me show again. I'm going to exit. Let me draw again. Sorry. So again, I'm with the function, I draw. From here, I go trace. And now I can walk over the curve. Perfect. I want to go to the point -2, x equals to -2. I just hit -2 in order to input x value. Hit execute to find the point. So if I don't press again execute, you can see that nothing happens. -2, execute. I find the point -2, 3. So we have here x value, y value. If I want to register this point, I hit again execute. And now the point becomes like bold, and you can see right here the point -2, 3. We're able to do it. Yes. Yes. Mirella, were you able to do it? Uh, you were you were muted.
Yes, I was. So
Perfect.
that menu up there, the trace zoom in yellow. So that is a fixed menu to use as long as I press shift.
Yes.
Okay.
So every time go shift and you can see all the functions here. So trace again, I can put one. Oh, sorry. Trace. So if you hit trace, you use the trace. So when you have this message right here, trace is on. When I hit it again, it's off. What happens right now when trace is off? You can move, you can adjust the function, you can adjust the graph. So right now I can move, I can zoom in, zoom out. So when you want to go over the curve, trace, and if you want to deactivate this function, go again, Shift F1 in order to go back to and adjust the functions however you want. So here I can adjust the function. For example, oh, I'm too far from the point I want to analyze, so I can adjust the function and hit again, Shift F1, and then use the function as I want. For example, is if I'm not seeing other points, I can hit Shift F1, and now I go minus to adjust the function. I can do this, for example. So Shift F1, and now I want to use, for example, 2.5. That's there. So this is nice when you try to see, because if X is on the domain, belongs to the domain, but Y doesn't, it's not, there is no problem about that because it will show X, but not Y. For example, you can see here on my screen that my calculator goes to -5 something to almost 8, right? So here's my domain. So for example, if I want to input X value equals to 5.5, it's okay. 5.5, I hit execute. So you can see here that I see X, but I don't see Y value. But I can see the result right here. So X equals to 5.5, Y value equals to 29.25. So again, if you want to adjust, just press Shift F1 and you can zoom out. No, so it's kind of okay. Or go over and go back. 5.5 right here. So you can adjust the points however you want. Okay, this is trace. Since you are with new calculators, it means that you're seeing exactly how I'm showing here. It means that You're seeing x value, y value. Remember that you can activate, if you want, derivative. How do we do this? We go to Shift menu, and you can see here, derivative is off. It means that it's not showing the derivative of this function at this point. If you want to activate, so by default, this function is off. Because normally you go through functions and then limits, derivatives. So by default, this function is off. If you want to activate, just hit F1. And then when you go and when you use trace function, let me adjust, yes, and use trace function. Now we can see both x value, y value, and also the derivative of this function at this point. So this is something that we have done, but it's also always nice to review this because it is useful. Okay. From there, we use trace we used. And now with derivative, you can see x value, y value, and the derivative. Zoom, we can use box not to zoom inside that box. Just be careful that some deformations for the function will happen depending on how you create a box. The best way to zoom in, if you ask me, how's the best way to zoom in and to go around a specific point? Let's say that we want around -2 and 0. And you want to make a box. So we go to Shift to zoom. So Shift F2. And you can use F1 to box. If you use this, the calculator is telling a message, select range start point. So basically, we're going to start like using a corner and a second corner in order to create a rectangle. So right here, I create this one and say, look, I want to do this. It's possible to do this kind of zoom. To zoom out, minus. But you're seeing that the function now is not in the same shape. So that's the problem with the box. So if you want to use box, you can use, just remember that it's going to deform a little bit the function. If you want to restore the view window, so now you you want to create a box, you want to restore. I always do Shift F3, view window. And I normally use this one right here, initial. So in view window, I'm going to go back, Shift F3, view window, and I normally use this one right here. So this is the view window. So it's showing me the minimum x. So it's going from -23, in my case, maximum 21.3. Scale, it's just showing how we're going to, how x is going to be plotted. So in 1 unit, y minimum and y maximum. So this way is it's not the way it's not the best way to show. So when you say you click initial, it's going to show without any deformation. This view window function is very nice in order to start any function analysis with the students. Why? Because many students can use the calculators differently. So sometimes you're going to plot function, you draw a function, and they don't see the function because the view window is too far. So it's always nice to have this view window set in the same screen in order to have the same screen among all students. Hit execute and draw the function. Now we have the same screen. Okay? But answering the question, how do I do a box zoom without using that function? We're going again to the window. And the best one, I normally use from here, initial, to have the same screen. And this one right here is square. So again, from this screen, I go Shift F3 to use view window. And I use F5 to use the function square. Why this one? Because you can set, I want to use a specific number for X, but I want the calculator to adjust the other values in order to not deform the function. So if I want to go to -3 to 1, let's say, so I set X minimum to -3 and I set X maximum to 1. You can see that the Y values, minimum and maximum, did not change. So it means right now that's deformed. I changed the X values from my screen, but Y values did not change. So I just put, while taking consideration X base, and then boom, the calculator will change automatically in order to not deform the function. So that's a very useful function for you, to students, for students in order to non-deform. So when I draw it, you can see that's the same way. So for me, I normally don't use zoom, just plus and minus. And if I want to zoom in specific number, I go to view window and set to either X or either Y, and then I ask the calculator to set the other values automatically. Is it clear? I'll let you to, okay. And all the time you can use minus in order to zoom out. So this is the best way to zoom in and zoom out, plus, minus, and using view window square or view window initial. These are for me the best ones to be used during the class. Okay. So trace, zoom, view window, and sketch. Sketch is the fourth function right here. When you go to sketch, you have in this one to clear anything that you have put into the calculator. It means that, oh, you've traced, you have used trace, and you set this point right here, and then another point, another point, another point, and another point. Let's say this. And then it's going to be kind of messy. So if you want to clear all this, you go to sketch, and then to F1 to clear everything. So when I go here, it's all clear. So anything, lines, points, anything that's plotted into the calculator besides the curve is going to be erased. Okay? So again, Shift F1, I start to put values like this. And then I don't want this anymore. I want to delete all the points, so I go to Shift F4, and then I go to clear. This function is also nice to draw tangent line, normal line, and inverse. Let's see the tangent line. So F2. So it's nice that it's almost the same thing, the same way as we do in trace. So you can go over the curve. You can input X value. You can go to 2, for example, or even just use right arrow and left arrow. You can input numbers and go specifically to that point. And it's going to show me the draw of the tangent line at this point. And the nicest thing here is that when the derivative is on and you hit execute, boom, it's going to show you the tangent line equation. So the equation for the tangent line at x equals to 1 is 2x minus 2. Same thing, minus 1, hit. So it does not show you the equation, hit execute, and then boom, you have now we have x, y, and the tangent line equation. If you want to erase all this, just go sketch and F1 to clear all the lines, all the points that you're drawing in your graph. Okay? There are several options here. So norm, inverse. So of course, inverse is not going to give you the answer, the inverse properly, but it's going to give you what, depending on the side you're taking on consideration. For example, here, we know that this is not a function, but that's the point that you need to discuss with the student. That in that case, you need to discuss that we cannot take all the points. So for example, here, this function is not inversible, but you can take from -1 to infinity. For example, in that case, 0 to infinity, or minus infinity to 0. Okay. All right. So you can plot, can draw different things on your graph: tangent lines, normal lines, inverse. But if you go here, you can also go plot circles, vertical lines, horizontal lines, and input text. So you can do all this in your calculator.
I think we have a question.
Yes.
Where did you find the inverse of the derivative again?
Where did you find the inverse? The inverse
Yeah.
The inverse.
in
So
sketch. In sketch.
sketch, inverse.
Okay.
And the other one you wanted?
Derivative, but yeah, that's also. Oh, tangent, sorry, that's what it was.
Okay, found it?
Which is, yeah.
We're good.
Perfect. So here you can draw the normal line as well. And then if you hit execute, you see the normal line right here. So if the derivative function is on, you can see the equation from the tangent line and normal line. But if it's not, it won't give you the equations. That's important to know. And then If you want to clear everything, Shift F4 and clear. So
So sketch and then CLS, that's clear.
yeah,
Okay.
all right.
Sketch and then F1 because
Remember that.
it said CLS. So once you had all of those points marked, okay.
So this one right here. Remember that you have options here in F6. At F6, you have options. So we have tangent, normal, inverse. If you hit F6, you have line, any line. You have circle, vertical. So just have a vertical line. This is nice, for example, to see, for example, if the function is 1-to-1, not the vertical line, but horizontal line. So if I go to horizontal line,
Yeah, exactly. That's what I was saying.
it's nice to, for example, to check if the function is a 1-to-1.
Where did you get the horizontal line?
So when you go to sketch,
Yeah.
but F6 in the arrow to the right,
Yeah,
that's when you have other options like circle, vertical, horizontal.
exactly.
What's the plot and line?
So plot. When you go to plot, you go for the plot. You just go select a point,
Okay.
and yeah, there's just points that you're going to plot. I don't. It's very rare to use these ones because you don't. It's very hard to go to that specific point that you want. You see, so
Right.
I don't find very useful, but you can use it.
Okay.
Other things that we might use from here. So plot on, plot off. So it's just plotting points. But for me, it's not very useful the way the calculator is doing. So that's the reason I don't go very far from. Um, yeah, select plot change point. So I don't normally see this very useful. But line is something. So I select a point. I select another point. I need to select a point. Let me select. Okay, I've done this one. Let me see. I'm not able to select. Let me change. Fine. No, it's not working. It's just select points. This is just points. It's not useful because you risk to go over the function or above and below, so it's not accurate. So those two I don't think very useful nor for teaching. I prefer those two. I prefer to use circle sometimes, but mostly vertical, horizontal, and pen is just to start a point and circle. So make a circle into the area that you want to talk about. This is as I found very useful because if you want to talk it to a specific area, you grab pen and draw over it, and then just go to clear in order to clear this mark that we have done. So again, we'll go here into pen, and then if I want to go and say, look, we want to analyze around here. So just use the arrows and then going to draw like a pen. And that's it. So pen, I find it useful. Horizontal, so tangent, normal, inverse, clear, of course. Horizontal, vertical, pen, and text. Text I can put here, and then hint, for example, let's see. In case you're using the emulator, you can use your keyboard. On the calculator, you need to, if you want to use the letters, hit Shift Alpha in order to log alpha, and you use only the letters. So you can log the letters using Shift Alpha. That's the A lock. So you're going to see this with the, so you can hit and put like minimal, maximum, in order to explore more the points. And then if you don't want to lose it, just do as I'm doing here, capture screen, and you can let here in order to use use later in your materials or for students. Okay. All right. F5, just remember, this is the most useful for papers. So when you have only one function, like here, and I press root, F1, it goes directly to the first root. You see here X and Y. Fun fact, you have in your calculator many variables. So from A to Z, you have variables, right? Every time that you use trace or use any function that you see X values and Y values, those X and Y becomes the one that you see on the screen. So right now, my X value right now is -1. My Y value right now is 0. So if you use in any part of your calculator, for example, run matrix, X equals to -1 and Y equals to 0. So it's very important to know that. So the points that you're seeing on the screen is automatically stored in your calculator with in X and Y. So you don't need to take notes because your calculator takes notes for you. So if I go to graph, I plot, and I use trace, and I go to this point right now. So right now, my X is equals is 1.779, and Y is 2.221, etc. So if I go there and see X value and Y value. So just be careful to store values into X and Y, because depending on the apps you're using, these values might change, as you're seeing right here. So just using trace, I'm changing constantly the values of X values, and also Y values. Right? Perfect. So it's very important to know that. In order, when you say root, to go to the next one, just hit right arrow, and so you go to the next root. Again, X values and Y values are changing as soon as I'm changing the roots or use trace function, etc. Maximum, this, just remember that maximum and minimum, we're talking about local ones. So local minimums, local maximums. So here we have a global one, but if you change the function, for example, let me put x cube, let me put like this way, -1, x minus 2, x plus 3. Right now, we have like a local minimum right here. So if I use gsolve minimum, first of all, it's going to start blinking. So I need to select the graph that I want to analyze. So I want to select this one, and then boom, we have a local minimum right here. So we're not talking about global, we're talking about local minimum in this case. In case of roots, we have 3 for the cubic function, the first one, the second one, and the third one. And in trace, now it's nice that when you talk about trace, you can see also the derivative.
Yeah.
So if you have
We did a class that looked at this also. And this was the class.
So it's also nice to make connections between the sign of the derivative and how the function is increasing and decreasing over time. Okay.
Also,
And in this solve, we have y-intercept. So just checking the point and put this point right here. So it's just a point belonging to the intersection with this x right here. An intersection is the intersection between two curves. So it's important to know if you have only one, you won't see anything. Two functions goes directly to the point. So right here you have the first one minus 2.65. And if you want to go to the next point, go right, and this is the other point. To the third one, in this case, just go right and see the third point. If you have more, it will show you. Okay. Remember that here you're seeing the two functions we are taking consideration. Also the names y1 and y4, x value, y value, and here you have something that indicates that you're talking about intersection. So it helps students to understand what they are doing. Okay. And one good thing that we did last time, just to make the review, was to calculate the derivative, the integral. So again, in GSolve, we have GSolve. We have more options at F6. And then to hit F3, you can make some calculations using integral. You have just integral. Integral using roots. So the limits are roots. Here, the limits are only intersection. And here, the limits are mixed. Can be roots, can be any point that you want, can be intersection. So this is very useful in many cases. But for this one, to find the area between these two curves, I use this one. You can see now intersection, I only goes through intersections. So if I hit intersection, I can only choose points that are intersections between these two curves. There is no other option. So I hit the first one. If I want to pick that specific point, I hit execute, and then it chooses the lower limit. Now I need to select the upper limit value. So I need to choose another intersection point. So here I can choose this one or this one right here. And the calculator gives you the lower limit, upper limit, also the integral, which is in this case negative, and also the area. It means the integral from this lower point to upper point, upper limit of the absolute value between the difference of y1 and y4. Good?
Can you do that one more time?
Yes. So again, we just learned about in Sketch to clear. So if you want to clear all this area, I go to Sketch and clear in order to clear anything, including these areas that we're including. So again, I want to calculate the integral between these two functions. Sorry. So I want this part. So first of all, I go to dissolve. In dissolve, dissolve stands for graphing, solving graphically. So anything about graph you want to solve, just go dissolve. And then I go to F6 to see more options. And here I have integral.
But then, what should we do next?
I'm gonna choose between the
And if you want just to calculate the integral in between the two curves, so you want to see the intersection between these two curves. So you don't need to make extra calculations. Just go here, intersection, and it goes directly to the first intersection.
next intersection.
In order to choose that specific point, because you can choose many points from that. In order to choose the first one, you hit execute. So you can see the line has changed. To choose the second one, just hit right arrow. If you want to pick this point, hit execute. If not, go to the next one. So if you choose this point right here, the calculator will calculate the area between these two curves just on this area right here. Let's see. I'm going to hit execute, and then this is the area.
Then, should we get
And
next?
then you first intersection. Oh, it's just, to go back. I know that matters.
I'm not listening. If you have any question, please just send to Mirella. So
No, yeah, I think they were just doing
okay,
it.
discussing it. Okay,
Too.
great.
Yeah.
Why the integral is negative? It's because they do the first function that appears on the calculator. In this case, is y1. In my case, minus the second one. In this case, is y4. Okay. So this is the reason the integral right here is negative. Because y1 is the one below and y4 is the one above. And the area does the integral of the absolute value of the difference. So it does not change in any case. Okay. So this is very important for the papers. We're going to see that again once we solve some papers. Also, it's important to make so here when you use the list of functions, you can change it. So for example, here we have the quadratic function. This is the quadratic function. And you can also plot its derivative. How do we do this? So go to the function that you want to input the derivative. Do you remember where we can find the derivative on the calculator? Not shift, options, and then
No.
now is F2, calculation, calculus. In calc, you can see the derivative. Again, option, calc, derivative. You don't need to repeat the x squared minus 1. You don't need. You can see right now in my calculator, we have a new menu with y, r, x, t, yt, and x. These are bold. You can see there's a difference between this y and the constant y. This x and the constant x. Because these are functions and those are constants. So if I use this y, you can see that's a little bit bolder than the normal y. And I can just put, okay, calculate the derivative of y1. So you don't need to repeat the functions because sometimes you have a very large function. So you don't need. And in the end, you just put x right here. So now you can plot the quadratic function and also its derivative. As plotting the other one because yeah, I recall. But this one in red is the derivative of the first one.
And I found at one place, I don't remember now where, some pre-stored functions.
Yes, I'm going to talk about it right in a minute.
Yeah, I don't know where. I just found that at one point.
Two built-in.
Wait, go again.
Let me see if it's two built-in.
F2.
Two, F4. When you're here, you have this function two,
Oh, tool, okay. Oh, all right.
and then built-in.
Built in. Okay, that's where I was. Thank you.
Welcome. So here you can do many things. For example, you can say what happens if I use, for example, let me delete this. If I press right arrow, you can see I have some options. So I can put like y1 plus 5. I can make some calculations with functions, some algebra.
So you do like transformations.
Giovanni says so that you can do transformations. Is that it?
Yes, yes.
I wouldn't know.
We're going to see some nice functionalities in a minute about these transformations that she's talking about. So also I can, for example, let's say that I'm going to use like 2x minus 5. And then I want to do, I can also see like y1 compounded with y3. I can also do that.
Is that times or is that,
Or is it composition?
Not time.
It's composition?
Composition, yes. In order to multiply, you have to do the normal one. So if this is different. So this is y1 multiplied by y3.
Okay.
This is different. Now we have a lot of things. So so here you can see in trace. And very nice touch is that all the time when you plot a lot of functions like we're doing right now, you can see the functions you were on. So here y1, y2, in green y3, y4, okay, and this is the compounded function, the composite function, and the other one is the making multiplication. So you can make some algebra in this application. Remember, if you don't want to plot all the functions, just hit F1 to select one, select your functions.
Just did that.
Because otherwise it's going to be kind of a mess. Nice. As Mirella was mentioning, in tools, you have built-in functions. But you may wonder why have A, B, C, why have these constants? Because is it possible to input? Yes, it is. So let me input like right now, like A x squared minus 1. Just like this. Please don't hit execute again. Just input the function a x squared minus 1. If you hit execute again, so the first execute is to confirm the function, right? If you hit execute again, you're going to draw the function ax squared minus 1 for that specific a stored in your calculator. So that's very important. So if I hit, for example, right now, execute, why do I have this function? Because a for me, a in my calculator, since this emulator is brand new, is 0. That's the reason I have this one. But you're seeing right here, in F5, modify, right? You see here, modify, right? If you press modify, so when you insert your function and then hit F5, now you have A and stack. So you can change the value of A however you want. So if I go right arrow, I'm going to change 1. That's the reason of step in the calculator. So I went from 0 to 1 because the step is equals to 1. And now you can see the old function and the new function.
Yeah, I've done 2 now.
Yeah, I know, only the.
So I did it.
If I hit it again, now you can see in yellow
Yeah.
the older function and the new one. So you can ask some pedagogical questions about what's happening to how the function is changing. So when A is increasing, what happens to the function? What happens to the graph of the function?
Yeah.
When A is negative,
Wait, how do you change A? I didn't get it. Maybe because I don't get the math.
Yeah, you select
so
modify.
if you use right arrow and left arrow, it's just adding, also subtracting one, because this step in my case is one. You can change this. You can put like 0.5. Now, when I go to A, it's going to change like from increasing 0.5 into A. So 0.5, 0.5, 0.5. Or you can input the value you want. So if I want to input right now 5, just enter it. If you want to just input 10, you don't need to go to all the values. Just enter 10 and that's okay.
Oh,
That's very nice to in order to work with the students. So if I want to include enter 10, just do it. -2, just do it.
is there a way to make it like that? Yellow is kind of hard to see. Is there a way to make that darker or color?
Is there a way to
Dark color.
change
Or
colors?
the you mean to the yellow, right? The answer the answer is no. Unfortunately, it's no to the yellow one. In the calculator, I think it's better than in the emulator.
Yeah, it's a little better. It's still a little tough to see, but that's
Yeah.
yeah, totally fine. I just thought maybe.
No, it's not possible. Let me. No, I've tried many times. Yes, it's not possible. Yeah, it's not possible. I've tried many times. But anyhow, this is can be very useful. So you can use transformations as well. So when I exit here, I can input several variables. For example, here I'm going to input age. Can input many variables as you want. So modify, and now we have two. And you can use up and down arrows in order to select if you want to choose the first one, the second one. And the right and left in order to increase or decrease from the steps. So here, if I go down, I have my, I select each variable. I use right arrow. I'm just moving. It's increasing half because my step is half. But if I want to change, I just input 1, and then I can go one by one. Remember, you can input, for example, any value that you want. So this is very nice also, so students can understand how it's changing. In this case specifically, they always have problem to identify that, oh, when h is -5, in fact, it's this way, it's not that way. Okay, so those built-in functions that you have seen, rel, for example, those you can use right here, and then just use modify to see how each variable, in order to not, you don't need to input all the function, you just need to use that one. And again, when you press exit, now you can work normally with that function. So you are in the modify function, you exit. Now you can use trace, catch, GSO normally. So you can analyze that specific function, well, that specific a and h in our case, and do some function analysis.
Okay.
So this is very nice. And remember, all the functions, many functions are here. So affine functions, quadratic functions, in two ways, cubic, and other ones. But as you have seen, you don't need to only use those ones. You can use the ones you want to use. So you can start like with just one variable and then adding another one, and then putting all together.
And gentlemen, just to make sure, everything we're going over today is all stuff students can see during an exam.
Yes.
Okay.
So one point that during the paper two, in paper two, we have, for example, a normal question would be calculate the derivative of this function. So the calculator does not gives you calculator does not give you an answer. I mean, does not give you the derivative, function derivative, but you can check if your answer is correct.
Yeah.
So imagine right here you have 2x squared minus 2x, for example, and then you plot the derivative. Then what do? I just check if my answer is correct.
Yeah.
Just for example, here I input like, oh, I think, imagine a student thinking, oh, the derivative is 2x minus 2. So we know the answer is correct. But how the calculator will give you that the answer is correct? The calculator will draw the first one, then the second one, and the third one. Pay attention. First, second. This is another one. I'm sorry. This is another one. Yeah, sorry. So again, first, second, and third. So we know those two functions are the same. So at least what the student may know from the calculator that, oh, my answer is not correct. For example, if we had a different one, and we say, oh, this is 3x cubed, x squared minus 2x. We know that's not correct. Then these two must be the same. So I know that's not correct. But it does not give you the answer. The minimum is that student can check with the calculator if the answer is correct. Okay? So it's a good way to know and check with your calculator. Okay. So from modify, so from graph app, we're done. So this is all the things that we can do with this calculator. Okay. The same list of functions that we are using on graph, you can also use on table. So we have a specific app called table. And you can use all the functions we have been using on graph, also can use on table. Oh. So you don't need to repeat the process. The difference here is that you need to set the table. So right here you can see set as an option. Just in order to set a table you want. So when you click here, you use F5, asks you, okay, what's the first X you want to count? In physics, for example, you have, for example, energy, and you can, I need to start from 100 to 0 and decay 5 units. This is a way to do a table specific for physics. In math, you don't want to use a negative step, so no worries. You can use like from -10 to 10, 0.5. Remember, the calculator does 999 points. So if you do a very small step and you have an extra over this limit, you have an error. Okay? So here, if I press execute, and as I see table, just a moment, because now I have many functions. I don't want that. Yeah, I'm going to just pick the first one. A table. It seems the derivative is on. Remember that function is very important. Since the derivative is on, you have this extra table. If you don't have derivative on your calculator, so you have derivative off, you only see x and y, not the derivative. And it's very important that you can edit this table. So, this is my understanding. What happens to minus 9.9? You can change the table as you want. You can make some changes and discuss in a dynamic way. So here, minus 5.2. And don't worry, if you should put your cursor onto the number, over the number, you can see the entire number. So here you can only see minus 130.2. But right when you put your cursor over the number, you can see the entire number. That's important to check. Okay. I believe we can make up a little pause. Mirella, you want to do right now or at 3?
What do you guys think? Now, I agree. A little break. Okay, we accept
Okay,
break.
15 minutes. So 2:40, 48, something like that. We return. Okay.
All right, thank you.
See ya. Thank you.
We're here.
Great. Can you hear me?
Jama, where are you?
I'm
In
at CASIO.
where is that? In Brazil.
It's in São Paulo, next to Santa Cruz station, subway station.
Oh, okay. São Paulo capital.
Yes, yes.
Okay,
São Paulo City.
just curiosity.
That's not. Let me show. Let me show you live visual effects to see what's behind me. So here's the watches, and there is you can hear some people playing the keyboards from Casio. I believe it's there. Let me turn around. So
Ooh. Oh
keyboards
wow.
and pianos right here.
Okay.
So these are some pianos that we have,
What's
and they're
that?
open. So many employees they come here during the lunchtime to just play.
Ooh, fancy.
I don't know if you can hear it, but there's someone playing a keyboard.
Oh wait, I can't. We can't.
Um,
Yeah, I
but
have
yeah,
a Casio keyboard at home. That's where my kids. Hmm?
That's crazy.
let me
They're the
bring
same
you.
company, right? Yeah, there are these companies like Casio and Yamaha that they have like both engines and also pianos and then motorcycles. Oh, that's so
Eu não
cool.
vou ser o pessoal que tá. So there's some another studio. Yeah.
Oh, look at that.
So yeah, this is the place that everything comes together.
Fun. At Casio, they have like studios for people to practice, and he's now in a room where people just go and play something at lunchtime or break time.
Yeah,
Nice.
that's nice.
Okay.
So okay, let's continue. So here, we were doing some tables, and you can see at the end. So we have, you can change the formula, you can delete, you can add rows, and the two last options here, you can see Graph Connect. This is this letter stands for, and Graph Plot. So the last one just to plot points. So if I choose this one here, I plot points. So it's nice to understand that since this step is very large, some way large, you have no idea what's going to come from those points. So that's interesting that you can exit, for example, here, and set, for example, 0.1 from -5 to 5. So when you shorten the step, look at how good it is. So if you want to start with the table, then plot some points, and then go to graph, I suggest to go with a 0.1 or smaller step, because you can see the difference between 0.5, 0.1. So this is something to take in consideration when you're using table and then go to graph. 0.5 is too large. 0.1, nice. 0.005, nice as well. Just remember, we have only 900, we have 900, almost 1,000 points. So here you can see how good it is to have an idea how the graphic will be. And this one, Graph Connect, it will connect two points by segment. So if I do here, you can see that there's not a curve, but it's in small segments. Since the step is very low, you can almost see no difference. But with a larger step, you'll be able to see the difference. So if I go and use a larger step, 0.5, you start noticing that you can see the difference. So these are the two different ways of plotting, doing graph. This one is to connect points by segments, and this one is just plotting the points. So this one's just this, and this one's just connect. This is normally used when you're starting studying functions, and the first thing you do is creating a table, and then plotting those points on the graph, and then starting connecting them somehow. So this is the idea to with the graphing calculator, and then you go to the graph. So if you want to use it, you can do by using table function. But again, if you want to use for plotting points, better to use it with a smaller step in order to get a better idea. Okay, like this one. Any questions? I believe that's okay. And to finish about graphing, the last one we are going to talk about is conics. Conic graphing. So here we have another app called Conic. You go there, you're going to see several built-in equations for different conics. So here you can see for different ones. On the menu F1, F2, and 3, it's interesting to me to see this is with different coordinates. So we see rectangle, which is the normal one, polar, and parametric. So when you hit F2, for example, it changes all the equations to polar coordinates. When you change to parametric, it changes that as well. Okay. So in different types of coordinates, you can see this. And once you choose it, let's say this one, you choose, you can also use modify, which is important. Of course, here is going to be a problem because B cannot be 0. So I need to put some values here before using modify. And now we can just change it the same way we did in graph. And see, for example, if you change A from 1 to 2, what happens? This happens. If you change A from 2 to 5, what happens? And it's very interesting to pose questions, to ask questions to students about what happens when I change those variables in the expression, and what happens to the graph. The same thing for age. So one nice activity is to start asking them to explore with the calculator, and then ask, okay, without the calculators, what do you expect to happen in those cases? So these are nice activities to be creating and exploring with them. So here I can change the values of each variable. the same way.
Would we be able to find like the focus?
Is it able to find the focus of the ellipse?
Yes. So once you're done with it, so this part is only to modify, right? So this part is only to modify. When you press exit, now you can explore. So I'm going to use shift. And you think the same thing? No. When you go to Gsolve, look at what happens here. Focus, vertex, center, eccentricity. So first of all, when you click on modify, you can only modify and change the variables, the value of the variables. Once you're done, you press exit, and now you can use Shift F5 to calculate the eccentricity, focus. What else? Vertex.
Nice.
And everything. Trace, you can go over the.
I use the record.
I love it.
So that's very nice.
Do they?
Then- And it's feet over. So that's the same like. Because that's from some.
Sure. Remember, if you want to just calculate directly, once you set your variables, if you click directly to draw, you just draw and I'm going to make some calculations with it. So if I hit F6 to draw, I can solve it. But if you want to explore, you can go here and use modify. So that's the difference. Modify, you're going to modify the variables and see what happens to the graph. Hit exit, exit, and then now you're able to make use trace, use Gsolve. Okay, so that's the difference. In everything. So it's not only here, but also in any other conic. So modify, I can change it. And then if I hit exit, now I can calculate the focus, for example, and gives it here. Remember, if I hit again exit, sorry, if I hit again execute, it's going to mark the point. So you can see here, this is the focus. Play a little bit. Okay. So this is important.
The math people are excited. They said very nice. They said very nice.
That's good. That's good. And for curiosity, if you want to see how all those equations are in the polar coordinates, you can also do here. Oh, that's an important thing that I forgot, so I'm going to come back to graph. Sorry, this is the only thing I missed. In conics, we're done. It's the things that we can do. But in here, is that we are using only functions, right? We're using y equals something, a function depending on x. But also can also change the type of the function. This is important to do, that you can use here on different kinds of function. So we have the normal one, x depending y depending on x, polar one, r depending on theta, parametrics, x and y depend on t. That's the reason here the we have x, theta, and t t. So if I choose, for example, r, you can see that the functions that I have defined, they remain the same. That means if I define a y function depending on x, they they remain the same. But the other ones, they change to r. Okay? So now I can, when I use tangent of 9 theta, you can see that the calculator won't use x anymore. So it's saying that the coordinates right now are in polar. Sorry. I'm going to plot this function right here. So tangent of 90 theta, and we can start playing with it. Hard. Hard. So we can play with it. Just to let you know that's possible, and also possible to put together. It means I can plot 1 plus cos of x and 1 plus cos of theta. And etc. You can start playing with it. Okay? That's possible to use, but also possible. Maybe this is not very helpful for you for the IB, but also you can use inequalities. That's important. So these ones are I believe it's very important. And you can see the difference right here. Now, when I input a new function, you can see a different sign. And now I can input, for example, x squared minus 6. This is black. We have the border and the area that we're talking about. I'm putting a different one, minus x squared plus 3. So it's very nice for inequalities as well. One nice activity that I do with the IB students, and it's very nice, is that after they see many functions, I ask them to create an emoji using only functions. And it's very entertaining for them because they start using the functions. And one question, and also for continuity, is also interesting is that when you have a piecewise function, how do I do this in the calculator? Because right now we're defining for the entire domain. How do I do just for a specific domain? So for example, I want to create a line but only between 1 and 2. How do I do that? So first of all, we're going to change to this one equal. So if I want to change, let's put like 2x plus 1. Imagine I have a piecewise function. So I have function defining 2 or 3 parts. And I want to write only the part that 2x plus 1 from 1 to 3. If I want to do this, it's almost the same way as we write. So you put comma and you insert the interval. That's it. So comma, shift plus, shift negative, shift minus to close the brackets. So this is the way that we used to say, look, I'm defining this function from 1 to 3. I'll let you do it in your calculator. And also the other ones. So when I draw it, I'm going to just show it. It's here. This is the function. So when you're going to define like in 3 pieces, just use 3 functions and define each one in each part. The question is, how do I do from, for example, 3 onwards? 3 to plus infinity. How do I do this? Let's say we're going to put minus x squared.
Hey, Jaman,
Yes,
I need to go now, but I'll watch the video, the recording.
no problem. Thank you.
Bye.
Bye. Imagine I want to define this function from 3 onwards. So again, the same thing, comma, 3. If you don't want to input like a upper limit, just don't do it. So I just close it like this one. So it's because in those calculators without CAS, they don't have infinite symbol. So just don't put any symbol at all. So it understands that we start with 3 and there is no upper limit. So it's going to define from 3 onwards. Let me, okay. Yes, now it's okay. And can you use trace? And you can see the difference. Of course, here it's very just
Just a sec. We have a question.
How to graph absolute value functions?
could you repeat the question, Mirella? Because it's
How
too
do we
far.
graph absolute value?
Oh, that's good. Perfect. That's very nice. So first of all, we need to input the absolute value. So here we put, for example, option, numeric, absolute value.
Oh.
Remember that you can also use catalog. In catalog, you can also look for absolute value. So here, x minus 3. And you can also input, for example, minus infinity to 1. This way. Welcome. So now you have this. one thing to understand is that, for example, here the function is defined from 3 onwards, and you can see here the derivative. The derivative is about the extension. There is an extension. This function, there is an extension to the entire set, and then the derivative is this one. Okay, just to be careful that we're seeing here the derivative, but just the derivative of the extension, not this function itself. I'll let you to input in your calculator. Now is the time to insert different ones, absolute value.
I always forget about the option.
Same here.
Because it's not on the. Okay, thank you.
See what else.
Because usually they just do it like add comments per se. I always forget about the option.
Is that integral?
It is, I don't know, maybe.
So it's like. That's probably.
Yeah, maybe like.
Yeah, because it's right next to this fraction.
Do you guys want to ask something? No, you figured it out?
Well, sure, yeah. Gentlemen, in options, if you click options and then go to numeric,
Yeah.
INT, but I also see INTG.
Okay. One good question. So the first one, let me go there. Good question. So option numeric, and you have this one and this one. INT is just the integer part of the number. So it means that if I put like integer part of 3.14, gives me 3. If I give integer part of 2.19, 89, gives me 2. So it gives me only the integer part. This one is the biggest integer less than that. Okay? So if I put, for example, 2.8, it gives me 2. Uh, 3.14. Oh, sorry. Gives me 3. This is the largest integer less than that. And you see no difference right now, but when we do the opposite, let's say minus 2.4, and this one is different. It's the biggest integer less than that one.
And then, is there a way for us to restrict significant figures on here, like? have
Yes. Shift the menu, you can, if you scroll down to display, you can go here and scientific and specific number. Let's put 3.
But then it'll be times 10 raised to the,
Yes, yes,
but it will be in times 10.
yes, yes.
Or it'll be 60 specified, okay.
Okay. So in summary, this is the difference between INT and INTG. This one is just the integer part of a number, and this is the largest integer less than that number.
Yeah, Giovanna will show you her artwork. Is it?
Oh, I see. Nice. Oh, so you're going to do what I'm going to ask you right now, which is, let me show you.
Giovanna is all about the challenges. You challenge her.
I'm a student.
I know.
So now is the time.
Students.
I'm just
Draw an emoji or a draw.
Oh,
I've done all this. I've done all this. I've done my by myself. So now is you can do an emoji. So let's start with the basic one. Emoji.
yeah.
Draw an emoji using functions using the Graph app.
Or draw psychedelic flowers.
Yeah, you can also draw flowers, a boat, and a sea. So you can see here that I use inequality functions and piecewise functions. Next stage, because you can also ask how you do all functions in black, all functions in blue. It's possible to choose. This is the only, and then I'll let you to do the challenge. Is that whenever you have a function, let's say, I don't like green. I personally don't like green to the simulator. So when I have to use, for example, the third function here, I go Shift 5, and I can change the line style and change the line color. So I go here, hit execute, and I change to cyan, yellow, red, magenta, blue, and then exit. Now I have this function in blue.
Wait, go
So
again.
now
Go.
I shifted 5
Shift.
format.
And then
I
Oh.
go on format.
Oh, I like this.
In line style, you have thin, thick, broken, dot, and thin. So have several options as well. So now that you know this, you know how to build the piecewise function, you know how to use polar function. Now I want you to create an emoji. I'll let some time so you can discuss. This activity is very useful among students. The ones when I tested, they were like amazed and trying because they can apply all the concepts about function into this moment. So I need to put the here, but I want that place. So they know, oh, I need to put +5, +6. So it's very nice to use it with them. Okay, so it's now left like 20 minutes for you to build your emoji. So you can apply all the concepts that we have shown here.
I don't have the mathematical knowledge.
Okay, Umbrella, you're safe.
Cheer you up, and then you can.
can you draw a circle here? Because we have
Yes.
y equals, can I make it like y squared equals something? How do I do it?
Yeah, you can use in two ways. That's a nice question. So have this first one. If you want to, students would say that I'm cheating. If I put, for example, 3 equals to R3 equals to 3, so you're creating a circle because a constant in polar coordinates is in fact a circle.
That's
The second way is to create the upper side and then the lower side.
oh,
So
okay.
students normally when they want to create like an emoji, they create like squared root and then the other part.
Okay. I like the
This is
first
kind
one.
of cheating with them because look at him.
I like the first one.
You have the circle, but this is the R equals to 3. So I have to change the type. So for the mathematicians, math teachers, please, this is the time to be creative.
Okay.
Okay.
Done? Let me check. Let me see from afar.
Yeah.
Oh. Yeah, I don't know if you're gonna be able to see because it has yellow.
It has a yellow.
Oh, I can see some part of it. Yeah, that's nice. If you turn a little bit, yeah.
It's like
Maybe like blogueiras with a dark.
Oh, that's nice. That's nice. That's nice. Oh, you've done it fast.
She had she was doing the face out of fun before. So now she
Oh,
just had to add the circle. That's why she had that perfect
oh.
question. Oh, and she changed the colors.
Nice. So students they want to input. Oh, I want to put hair on my emoji. I want to do like a
Stop.
tone. Yeah, just change and customizing. So it's very nice because they can use math functions, but also doing a creative activity. Okay, I'll let some time for the other teachers because she was guessing that I'll come with this challenge. But anyhow, it's very nice when you do this with the students.
I know. It's,
Then I'll have the prize for that. For the
uh,
Prize?
Yeah. I like it.
So Giovanna is saying that when she does these kinds of challenges with her students, she has a prize. What's the prize? Is it candy? Always.
Oh,
So excited for like.
They're so excited. Yeah. And sometimes they're excited just for even seniors, just for a sticker or a stamp, you know?
yeah.
It's so weird because like.
It doesn't matter, even like in high school, it doesn't matter. No, it's because they got it, they earned it. Yeah.
Yeah. Uh, let me put like minus s squared. This is 3 plus 3. Also, you can modify if you have a function like this one and you want to modify, not with this modify, sorry, you can use, sorry, type, and here you have convert. You can convert an equality to a different one. So for example, here, I can change the same one and change to inequality. Oh, not this one. It's minus 3. You can start building person.
Oh my God.
Yeah.
That's nice. And it's a nice
Yeah.
way to have students knowing how to use not only math, but the calculator.
Yes. 2, 3, 2.5. 5, 2 pi. Eight.
What we have is like in the interval notation, you use the, like, for example, 5, comma, shoot. would it still bracket or it doesn't have to be in the right order? Like from when she creates,
Good question. I'm going to input here. Let's put like the opposite. 3, 2, 1. No.
okay. Thank you.
Welcome.
Well, I just did shift paste. It was very nice. Paste button, I copied it on Traveler. I wanted to keep it this way.
Nice.
Mm. Six. Six. Minus 4. Plus
It's so good.
yeah. Bird. Swap. Minus 2. Oh, I'm the opposite.
All right, this is it.
Are you having fun?
So what I've created so far.
Oh, yeah. Do you want to show it?
There's a, let's see if we can.
How do you do it? I think, okay.
That's nice. That's cute.
I'm almost.
Ooh, it's
That's
a lot.
cute.
Okay.
That's very cute.
Yes. The girl.
Oh, I'm going to send you. There's some on internet. Okay, now we can see. This one here.
This would be a great project for the freshmen to do on the
Really, you can see the link.
Okay, let me open it.
I like the title of the article.
My goodness.
Oh. My God.
Math geek with too much free time draws adorable sad dog with 181 math function.
You guys know, you guys know Felipe, all of them.
Felipe what?
Felipe.
Yeah.
Which Felipe?
Oh,
Very
he made them.
No, I
He
don't.
made a self-portrait on decimals.
Yeah.
He made a self-portrait
He's a decimals.
using decimals?
Yes.
Desmos.
No, this is Desmos.
Desmos.
It's
Wait.
a tracking calculator, but on the computer.
Is that, John, is that Desmos or is that?
Yes.
CASIO? Yeah.
This one is Desmos that you're seeing.
Oh, wow. Okay.
And the patient. I did not.
Now.
Like, I'm already one function.
If I knew the math, I think I'm that kind of person.
No, I'm not. I would be like, after cheer, no, I don't.
Okay, yeah, I don't know.
I'm not.
I don't know if I would or not. Have no idea.
So this is the thing that you can do. Students can start with the basic one, like this one. I'm trying to draw a girl with some hair out of it. But again, that's the one they're going to do. So try new things. And it's very a good way to attract students that are not math students. They don't consider themselves as math students, but they're studying mathematics. So this is very nice. And by the end, in your case, if you're doing an emulator, just, or even if you're doing on the calculator, you don't want to delete, remember, you can go here in tool, graph memory, and store in one of the 20 lists that you have. So if you want to save for later, store at the end. By the end, you can store in one of the lists, like list 2, 3, 20. You can use it whenever you want to recall those functions that you saved. Just go and recall list number, the one that you saved.
How did you go to the list again? I don't remember.
Tool. In here, go on tool,
Uh-huh.
graph memory.
Oh, okay.
Oh, and then you can store and recover.
Yeah, you can store the list of functions that you've just used.
So wait, when it says store in graph memory, it would store this current list.
Yes, it's
And
the
then
whole list.
I would store it to the graph memory 1 until 20. So
Exactly.
I would have 20 lists like these to store.
Yeah.
Okay.
So you can store up to 400 functions.
Okay.
But just remember, that it's very nice to have an empty list saved to save time. So normally my first list is empty
Yeah.
because imagine I finished my class, I'm moving from one classroom to another, or there's a new group coming, and I need to use functions. So right now I need to delete one by one. So what do? I recall
Yeah.
the list one. In my case, is empty. So when I do this, empty.
Okay.
So if I go to recall, to graph memory, recall list 2, I have all this. It's very useful.
And then how can you erase something that you have in the next one?
So for example, if you want to make a change in list 2, just by the end, override,
Okay.
just override. So I don't want, for example, here in my case, I don't want to use those, let me see, those ones. I delete, and delete. And then I go to graph memory, store list 2.
Okay, thank you.
You're welcome. And now I move to another class, empty list, because otherwise you have to delete one by one, and it's very painful.
Mhm.
So
Okay,
I'll let 5 more minutes for the ones that are finishing the.
So I think it's only them now, right? Because we have 4 people, and
Okay.
then Thiago went to teach AP, and now we have both of them have finished their smiley
Okay.
faces, and I don't have the knowledge to do that.
No problem. No problem.
I think we're
So
done.
this is the last tip, just to recall the last tip. Before you plot, because it happens a lot with students, we're going to see in some case. It's very nice you before you plot you do the first plot, the first draw, go shift, view window, and adjust the view window to the same one for every student. You can use like initial just to be sure. This is very useful. You're going to see how, but this is very useful. They need to be in touch with view window at least. Okay. So talking about graph, table, and conics, we're done. Okay. So let's go to statistics. Now, Mirella you're going to be joining us because we're going to be.
Not that I know a lot. I'll have to relearn statistics to teach DP biology. But let's go. I'm a good student too.
Yeah. So when you go to statistics, we have like 26 lists here, and you have 999 rows. Of
How
course,
many?
you can 999 rows.
Okay, I wasn't sure.
Yeah. You can import CSV files. So if you have some data, it's possible you put your CSV file, for example,
Oh, found it. Okay.
you can send your CSV file to all your students and say, guys, just put your CSV file into your calculator because you're going to be using this file to the next class, for example. You can do this. So CSV file, again, you're going to this, F6, again, CSV file,
Last option. Okay.
load, save as, and save. Also, if you want to create one and save, you can also save the CSV file and use in your computer. These settings is just to understand how it's going to be the separator and decimal symbol. That's it. But that's how the application looks. 26 columns, 999 rows, but you cannot go to the second one without filling value to the previous one. So I cannot go to the second row without filling any value to the first row. So I need to put at least 0, and then I go to the next one.
Okay.
Of course, here I'm just pressing the value and hitting execute so can confirm the value into the table. But imagine I want to create a list from 1 to 20 or 1 to 40 or 1 to 100. How do I do this? Let's do it. So first of all, when we are in the cells, you're just inputting the value for that specific place. So if I'm here, I'm just putting the value for that specific place. If I want to create a whole list in a faster way, I have to go. Sorry. I have to go to the list in order to make a list calculation. But no one wants to put 1 to 100 manually, like putting 1, 2, 3. So there is a faster way to do it. So here you go to options. Remember that we had the same option in your matrix. Now we're going to use lists right here. In your matrix is not very useful, but in here it's more useful. So go to list. And you can see here, there is something called sequence.
Oh.
Okay.
Whatever.
So you're going to be showing like this. My cursor is in list 1, and now I have sequence. There are five arguments. First one, the function. Since you want to use from 1 to 100, just put x, because this is the function. The second one is the variable. So you're going to tell the calculator, okay, you have some variables there, but which one's the variable? And you can say x. So it's just doing the function x and the variable x. The three last ones are something that you have seen the calculator. Begin and stop. So if I want to create from 1 to 100, I start with 1. I finish with 100. And my step in this case, since I want just the integers, is 1.
Mhm. Okay.
You hit execute,
And it's
it's
also
done. It's done. For mathematics, let's use list 2. Imagine you want to make mathematics. I want to see the squared numbers. So you can create the same thing. X squared, square, 1 to 100, and 1. This is the first 100 squared number.
Could you remind me what are the arguments again, please? I remember
So
the, but okay,
first is the function.
okay.
Second is the variable. So if you're choosing A, N, B, T, you can change the variable, but you need to you can change the variable.
Okay.
So you need to say which one you're talking about.
Okay.
The third is the begin. So equals, they're going to start x equals to something. So this is the first x value. This is the final x value. Not necessarily something that you're going to use. You're going to see this.
But it's
And
up until that point that you want the function to, okay.
imagine you put in like x, starting with 1 to 20, but step is 5. So you're going to do x equals to 1 at 5, x equals to 6 at 5, x equals to 11 at 5, x equals to 16 at 5.
But then it stops.
Exactly.
Okay.
Even though if you tell me, Jama, I forgot, how do I find this information? Remember that we have the catalog right here in yellow. So you press shift catalog.
They showed the arguments.
Oh,
Yeah. Now you're going to use SEQ. Where's Q? My calculator here.
yes.
And you can see there is a keyword code.
Q.
And you can read it to your smartphone and see the menu only for that part. So it's going to explain to you. This is the keyword code.
Wait. I wanna do that again so that if I need it again, so I found sequence there, and then I would hit QR, and then I will read this QR code, and then it opens the help.
Yeah.
Okay. So it's not built in. I would also always need a device
Yeah.
to open the help. Okay.
So
Try this
this
one.
is what you're going to see. Mine is in Portuguese because the computer is in Portuguese. So this is, we have what it is,
Let me check.
and look,
Oops. All right. To generate a sequence of numbers, okay?
Oh, yeah.
so this is very useful for students if they don't remember, even for us, if you don't remember how to use a specific function because it's been a long time, it's because yeah, you can just recall.
We have to remember this, guys, to use this catalog. Because we were talking earlier today, Giovanna, about forgetting some of these things because we're just having this very intensive training. And so Shift 4 creates that possibility of us generating QR codes to go and look for the Shift 4 opens the catalog. And then you can just use the letters to search for a function, and then it will generate a QR code for us to look for help, that specific help in the menu.
Or even if you are preparing your class, let's say that you're going to give a class and you're going to start using statistics and going to use sequence. You can come here, copy this, and paste it on your presentation. Because it's
So they will already have the QR code, and if you need help remembering how to use this, here's the QR code.
or even here, I can put like a QR code right here.
And we could use it. Mhm.
Yeah. Now you can read your
But
QR
then
code.
you have the emulator, right?
Yeah. If you're using the emulator, you can input here. If I want, just copy this and put my presentation. So you can use whenever you want.
Mhm.
And it's very useful because I don't want. If you have any questions, read this QR code to know how to use the sequence function, for example. And
Okay.
it's also important for students to understand how that if they don't know a specific function, they can also look up by doing Shift 4 and using the catalog. Okay.
Uh-huh.
Yeah.
For organization, I can input here, for example, x squared. It's very useful also by we're using this to put some names right here. So this is more useful for inputting names or values as I'm doing here, because imagine that I'm doing something and a student for some reason was not paying attention, then what's happening? This is very useful for chi-squared test, for example. I'm going to input like observed data. No, I forgot. Observed data and expected data. So at least I put them, look, this is expected data and this is observed data. So this is very useful when we're dealing with many data, a lot of data, and we want also the students to pay attention to this is about observed data, this is about expected, this is about the sequence, it's about the function, so they don't lose any information. So we can also use this during in the emulator. Okay.
Okay. How do I see? Can I see the sequence, the kind of the rules, the arguments that I use from a list?
No. This is something that you can't. I'd love to, but it's not possible.
Okay.
Here's only on the values. I'm going to send anyhow because you're not the first one to ask. I'm going to send this. I'm going to submit this request to Japan because many things we're requesting and they are accepting.
Ooh, nice.
That's not, for example, I don't know how much if the others were using graphing calculators before, but in the past, when you're hitting this key in the calculator, it was showing the e, the exponential. So in the past, we were hitting this key and just showing e to the power of something. So we request in Brazil, we requested to put 10 to the power of something, and they changed it. So many things they were implementing. So that's nice.
Yeah. Yeah, it would be
So
just to go and, I don't know, go to the list. And if you hit sequence, it would show whatever you put there instead of opening a new one for you to put.
Yeah.
Right now, what it does is that it opens the space for you to create a new sequence, but it doesn't
Yeah.
show what's there.
right now, if you want to do this, I would say this. If you want to, even though it's not, you know that here they don't, we can sound. This would be something closer.
Mhm.
Because you cannot input a lot, but this would be closer to what you're asking. But,
Okay,
okay.
and then the last arguments were the steps. So if you had one, right, on the list.
Yeah.
If you had two, it would jump from 1 to 9, and then from 9 to 25, and then so
Yeah.
on. Okay.
Yeah.
Got it.
How do we delete others?
How do we clear lists?
So how do I clear a list, a specific list? Just go. Let's go here.
Where?
Options.
Oh, sorry. Okay, here. So in delete all.
But where do you find it? Options?
No, you go to the first. You press exit until you find this.
Oh, got it.
Oh, I see.
This is the quick menu. This is the quick menu. So this is when you press exit as much as you can. You hit you.
The first menu that we have when we enter statistics. Okay.
Yes.
So F6, delete.
F6,
Okay.
delete all.
But if I hit delete, it will delete only the list that I am, because
Yeah.
right now, did you hit delete or delete all?
Delete all.
Delete would delete only the.
Delete all is all the information on the list.
On the list. So if I had 4 lists and I wanted to delete all 4 lists, I would still need to delete all in each one of the 4 lists.
Or that's something that I'm going to, the same thing that we had with functions. We're going to do this here.
Oh, save it as a.
Yes, an empty list. Yes, we're going to do the same trick. Just let me remember. Where is it? Because okay, I got it. So if I go to Shift menu, I have here list file.
Mm-hmm.
Or what's more useful, I'm going to have an empty list. Now I have an empty list, right? Empty list. I'm going to CSV file and save as.
Oh, I have done this already.
Oh, I can't. I'll put just one here. Save as.
Oh, if it's empty, then it can.
Okay, saved.
You lost me.
So I'm going to put just one data,
Okay.
just one, to trick the calculator.
Okay.
And I'm here in the first menu that we have,
Mm-hmm.
and press F6 until you find CSV.
Oh, okay. We're
So I'm going to save this empty, almost empty list.
okay.
But then once you hit like save as.
Save as,
Oh,
and I'm
yeah.
going to put 1.
So it's.
I'm going to overwrite, and that's it.
And do you recommend saving it in a specific folder or root or how?
Not specific folder because, well, if you have extra projects, I believe in those cases you need to open a new folder because you won't be able to see here, for example, the Python files, for example. So you won't be able to see because it's only CSV files and etc. So it won't be mixed. So
Okay.
like, here, don't think it's important. The other option is that you have here a list file in setup, settings, shift menu. You have also this file list. There's the second way to do so. So you can save up to 6 lists of lists.
Okay, go again. So
Shift menu,
shift menu, list file.
list file, and you press F1 and you can choose a different one. Let's say 6. Now it's empty.
Yeah.
So it's a different way to do so.
Okay, now it means that I am in file 6.
Yeah.
So whatever I do now, it will be in file 6. Okay, let
Yeah.
me try. Give me a minute then, just to see if I got it.
This file.
Um,
Just like execute it. Oh, you're the shifts.
oh, okay.
Yes.
Shift menu, list file.
Where?
6.
Where?
Okay,
Okay.
all right.
Uh,
But so this is kind of quicker, just being, okay.
To move from one class to another and not losing time. Because I would say I'm going to say that it's very you can use many lists very quickly in a class because you're going to start using the first one. You're going to make an exploration, so students will be doing like 2 or 3 or 4, and then quickly can use like 10 lists, just like that.
Mhm.
Well, I'm going to stop the recording because we're
Our time.
yeah, time.
TAA works, I keep on like mashing